Hi, this video is going to help you with our all-out problems with the rational root. And we're going to kind of do a mix of old school and 21st century with the graphing calculator just to make sure we understand everything. So let's go through this framework on how to graph a polynomial, which we have up here. Let's start with number 1. What is the maximum number of roots for the equation above? You can say roots, you can say zeros, you can say solutions, but the maximum number will always be the highest exponent. So they're basically asking you for what's the most number of times it can cross the x-axis. So number 1 is 3. Number 2, if you didn't have a calculator to see what they were, you could list all the possible rational roots for the function above. Rational means the number could be written as a fraction. So all whole numbers can be written as a fraction. All fractions obviously are fractions, but no square roots, no imaginary numbers. So anything that could possibly be a root, that's rational, will have to include the factors of the last term. The only two things that go into positive 1 are plus and minus 1. And that's all over all the possible factors of your lead coefficient. So there are 4 numbers that go into 3 evenly, and they are plus or minus 1 and plus or minus 3. So now when we look at this, we should then off to the side list what the actual rational answers could be. Well, if I take either of those numbers and divide them by 1, positive 1, I get themselves. Or if I take any of these numbers up here, plus or minus 1, and divide either of those by negative 1, I get the opposite. So I basically still have plus or minus 1. Now if I take 1 divided by positive 3 or 1 divided by negative 3, I could get positive or negative 1/3. Or if I took the negative 1 and divided it by the 3, or the negative 1 divided by the negative 3, I would get plus or minus 1/3. So there are actually 4 possible rational roots, 4 spots where it could cross the x-axis. Next, number 3 says, draw a sketch of the function and label the zeros, roots, x-intercepts. We know those words are synonyms. It may be helpful to set your x-min equal to -5 and your x-max equal to 5. So what I'm going to do is I'm going to take my calculator, press y equals. You will see that I already have it in. And anytime I graph, I always choose zoom standard first. And it graphed it. Now, I gave a suggestion here. I'm not saying you have to. I can really see a lot, but this is a little tight in here. So I kind of want to zoom in a little bit. So what I suggested was hit window and make your x-min -5. And your x-max 5, because then when I graph it, I can tell just a little bit better where it crosses the x-axis. So I'm going to copy that onto my purple paper here. It looks like, if I'm reading it correctly, it is crossing at -1. It is crossing somewhere between 0 and 1, which I'm thinking could be 1/3. And it's also crossing at 1. It is going up, down, and back up again. So what I did was I just tried to copy my graph over here so I have a picture on my paper to use. And it says label them, and I'm fine with just putting some bulging points so we can see where they are. Because to be honest, I'm not totally sure on where that one is. Now it reads, looking at your sketch, which of your possible rational roots is a definite root to try? You may list more than one. Well, I'm pretty certain that -1 and positive 1 are answers. I could also, to be honest, I think there could be 1/3, but I'm not totally certain just looking at the graph. So what I'm going to do is I'm going to go down here. Directions for 5 say, using synthetic division, if you like long division. Sometimes you can do factoring if once you have it down to x squared, or the quadratic formula to find all the roots. Start with one you know for sure. I think I'm going to use positive 1. Whatever the root is that you're going to try, you actually use the exact one. So I'm going to put a 1 here. and use synthetic division. So I'll go to my top to make sure I have my coefficients. 3, -1, -3, 1. So 3, -1, -3, and 1. And I'm going to do synthetic division. Remember, we bring down the 3. 1 times 3 is 3, and add. Gives me 2. 1 times 2 is 2, and add. 1 times -1 is -1, and my remainder is 0, which is not a surprise at all because I chose one where I thought the y value would be 0, like that was a solution. Now what's left is a quadratic, so I'm going to write that off to the side. 3x squared plus 2x minus 1. And I could factor that or use the quadratic formula. I'm going to be honest with you, I tend to go right with the quadratic formula, which is the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And I'm going to plug that in, so I know that my solutions for x could be the opposite of b, which is -2, plus or minus square root b squared, which is 2, minus 4ac all over 2a. So I have that all filled in, and now I like to do the discriminant next, and I'll put that, I can do that in my head. 2 squared is 4. -4 times 3 is -12. -12 times -1 is +12. So I'd have 4 plus 12, which is 16. So -2 plus or minus square root of 16 over 6. I'm not saying you couldn't use your calculator for that. I really like this problem because I know the square root of 16, which is 4. And then I can actually even find my two answers. If I do -2 plus 4, I get 2. 2 divided by 6 is 2/6, or I prefer 1/3. And then if I did -2 minus 4, I got -6 divided by 6, which would be -1. Okay, now just as a heads up, if you are not a synthetic division person, when you wanted to try +1, if you really like long division, then you have to divide the factor the binomial that it would factor into if that is a root. So you would have to write this one all the way out if you would prefer long division. I do not prefer that. I like synthetic. And if you would look up here, if you did not like using the quadratic formula, I'll actually draw an arrow down here, make sure you can see that. I could have taken it and set it equal to 0 and factored it. Many of you like grouping, so you'd have to go 3 times -1 is -3. And then you'd have to think what numbers multiplied together give you -3, but add to give you 2. And those numbers would be +3x and -1x. And then you'd have to factor out a 3x from your first 2, and you'd get x plus 1. It's getting a little small here. I hope you can see it. Maybe I'll zoom in. Okay, and then I'd have to take out a -1 from these, and then when I do, I'd get x plus 1. Oh, thank goodness these are the same, so it factors into x plus 1 and 3x minus 1. And then if I really like factoring, I'd have to keep going, and I'd have to set x plus 1 equal to 0 and 3x minus 1 equal to 0. And then I would subtract 1 from each, and I'd get x equals -1, or I'd add 1. 3x equals 1, divide by 3. Oh goodness, this is getting crowded. X equals 1/3. Now, those are just other options, but to be honest, I am a synthetic girl, and when there's a quadratic, I like to use my quadratic formula, and I also like to use my program to even double check. So if I turn on my calculator and hit program, I have one program in there that's quadratic, and I could put in the 3 the 2, -1, and I get the 0.3333 and the -1. The 0.3333 repeating is the 1/3. The -1 was my other root, and I also have my discriminant listed there, which is what would be underneath the square root. Okay, so let's flip this over on the back. We still have 2 more steps. On the back, let's see, number 6. List all the roots. Oh, I have an extra word in there. List all the roots below. Be sure to give exact answers and approximate answers. Well, let's see. 1 worked. So I knew 1 is one of them. When I did what was left here and did the quadratic, they actually came out nice with the quadratic formula. So that is 1/3 and -1. So I have those all, listed there. And it's also nice to go back to your graph and say, like, is that really where it was crossing? -1, I did think that was 1/3, and +1. So it's so nice to be in the 21st century where we use these and we can check our answers. All right, last but not least, I would like you to identify any maxima or minima of the function and describe the end behavior. So I'm going to write, I believe there is a maximum, and maximum would be a turnaround here, like a hill. And there's also a minimum. I call those your valleys down here at the bottom. So there is a maximum of at, I like to get this set up on how I would write it. There's one minimum. So there's a minimum of something, and that occurs at x equals something. Make sure I have x equals up here. Then I also need to do the end behavior. If you write as x approaches -infinity, that means on the left, on the very left end. And if you write as x approaches +infinity, that's talking about on the right end. So let's see. I'm going to look at my graph again. Okay, so if I look back here at my graph, I see one hill and one valley. To get my hill exactly, I will hit second calc. I will choose max, which is number 4. I will make sure it is blinking. Hopefully you can see that on the left of the top of that hill. Then it asks me for the right side. Whatever the guess is fine. And then it says a maximum of -0.4768 and 1.8778771. So the maximum is actually the y value. That's like the height. How tall is it at that spot? 1.88. I like to round to the nearest hundredth, and that occurs at x equals -0.48. And that's my only hill. I know it's not the very highest point because this goes up forever, but that is what we call a relative maximum, like one little hill in there. Let's also do the minimum. That's where your valleys are. Make sure you're on the left side of the bottom of that valley. Then you go over to the right. And whatever the guess is fine. The maximum occurs at the x value of 1.17, but the x value is actually 0.93. So that's your minimum. I hope I said minimum there. So your minima, that's your valley, your point down here at the bottom. That occurs at 0.93, and the minimum value is 0.93. That's the y value, and it occurs when x is about 1.17. Yeah, that's not the lowest point. It's not the absolute because it goes down forever over here, but it's just one low point that we have there. Last but not least, the end behavior. Basically, when they write this, they're just saying, what is happening on the far left end? And on the far left end, it is going down, down, down forever. So that means the y values on the left are going down, and that's how we write that. They're going down forever towards -infinity. This says as x approaches +infinity, that means the far right side of your graph, which is way up here. What is happening to the y values? Well, they are going up forever. So if you think something is going up on the right, this is how you write up, and that's how you write on the right side of the graph, on the right end. This is how you write the left end, and they are going down, so we write it like this. Now, I will be honest with you, when we drew our graph, we are a little smarter than the TI calculator. We know it goes up forever and down forever, so we added arrows. So I hope this helps you with number 2.